Rugged. Ready?
Okay, ready now.
Alright, so just to recap, we turn this on, let it get down to 20, and let it chill the system for at least 15 minutes. Open the nitrogen, make sure it has at least half full. I'd say around like 1250 psi should be enough. We then flipped the UV switch about 17 times while trying to get this active. When this lamp ready light became green, we pressed the red ignite lamp, and miraculously it finally worked, as you can see by the green dot on lamp on. So at that point, we can now engage the instrument. So simply this power switch right here, you can turn that on. The last thing that you really need to do is get into the computer software. This computer should always be on. You can tell it's on, obviously it's a PC, so just the button right there. So that's good to go. So we'll leave the monitor generally off. So just turn that on, and it should be ready to go. All right. So from here on is really what's not written down here. This is how to work the software. So the program that we use is called Model 14 Spec. So you can just open that up, let it do its thing. Alright, when it says it's ready down here, there are 4 things that you need to do to set up. The first thing that you should do is to change the temperature. You can do that simply by clicking on the temperature there. It's set to be 25 degrees. We're going to start our runs at 4 degrees, so number 4. And after everything, you always need to hit enter. So 4, enter, and then return and bring us back to the screen. And as you can kind of see, it'll start going down slowly and surely. The next thing we want to do is adjust the wavelength. As I told you when we quantitated on the UV, we use wavelength equals 260. So once again, 260, always have to hit enter, and it'll move it automatically, as you can see and hear. Alright, so now we're at 260. The next thing that we want to do is to configure the experiment, and this is this menu up at the top here, configure experiment. Click on that, and there's a couple things that we need to do. The first is, say, you want to give your experiment a name. So here we're doing the annealing of our poly A6 and poly T3 sequences, so I'll just write poly A6. And I think this is pretty sensitive with like characters, so you have to like write out the word plus. Poly A6 plus poly T3, temperature and salt scans. Basically just saying I'm doing 4 to 95 degrees at varying salt concentrations. Again, always hit enter when you're done, and then I'll just copy this and paste it down here and give this experiment name the same thing. So those two are good to go. We've named it. After that, we need to say what type of experiment, that we're doing. The last setup was kinetic. We don't want that. We want a temperature scan. So just go to temperature right here. Also on here, you should already see the wavelength is set to 260. The set point for the temperature is 4 degrees. And we want to display our signal as absorbance instead of transmission. The last thing that we want to do is that we want to make sure that we have the correct type of parameters set up for the temperature. So while you're in this box, go to Experiment Configuration. It's a drop-down menu. Go to Temperature Experiment. So there's a few things. We want to start at 4 degrees, good. End at 95 degrees, good. We want to take an absorbance reading every 1 degree is what the temperature step is saying. I don't know what this means, but I never change it. It's 0.1. And then equilibration time. This is saying that every time you get to the next degree, you're going to leave it at that temperature for 30 seconds before you take the absorbance reading. So leave that there. Averaging time, don't know what that means. A couple of other things we want to do. We want to return it back down to 25 at the end of the experiment. I should say up to 25 at the end of the experiment, because we will have it do a reverse temperature scan. We don't necessarily need the data for that, but it will, in effect, rehybridize, which is always nice, should we need to do anything else with this sample. And here, for the reverse hold time, this is essentially like the same thing as the equilibration time, so just a half a minute on the way back. So this all looks good. Temperature step, again, that's just saying that the step is 1 degree. So make sure that's selected. So you hit OK. So again, we've renamed. We're at a temperature scan, wavelength, and temperature are good. Absorbance. So last thing you want to do, and I've made this mistake 1,000 times, do not click the X out of here. Click on Exit, Save Configuration. Okay, so again, it's very finicky about the characters. So, so again, now we say Exit. I have to do the same thing down here too.
It's very character sensitive.
Yeah. Basically, just don't use any special characters.
No, yeah.
So again, let's hit Enter after both of these. So saves. Now exit save configuration. Okay, we're good. And just to make sure it's still there, go back and check. Okay, there's our names. There's our parameters. Our temperature parameters are the same as before. So we're good to go. Okay, that's 3 things. I said we need 4. Now, I showed you the UV cuvette holder earlier had 5 slots.
Yeah.
So as such, you want to make sure that you label all 5 of these. And that's right here where it says signal cell 0. This essentially lets you say not only which cells do you want to take signals from, but what do you want to name them. Now, we know that we want to use all 5 of our cells. It's not 1 through 5, it's 0 through 4 for whatever reason, but same idea. So just click on all of these that you want them to have their absorbance read. It'll always start at the current position of cell 0s. Don't change that. Don't change the stir time. Now you just want to rename these. Conveniently enough, all I need to do is change these 6s to 3s. Again, enter after everything.
Click enter.
And again, this is not very finicky with special characters. You can write whatever you want, but there is a character limit, so you kind of have to shorthand it a little bit depending on how much you want to say. So I have this set up such that I'm going to...
There is slash in A6.
So I have this set up such that my first cell is going to be the lowest salt concentration, and then going up 50, 100, 200, 500, up to 1 molar salt at the very last cell. So now you can see that we've done the 4 things. The temperature's already at 4 degrees, so just in that time, we've already managed to get down to the temperature we need. The wavelength is where it should be. We have our cells set up, and we have our experiment set up. So at this point, we can kind of just let this be, and we're going to go into the cold room and get our samples prepared.
Okay. It's still recording.
Okay. So we brought everything into the cold room. We still need a couple things that I didn't bring in there yet, and that is just a balloon full of nitrogen and a couple of Kim whips. So the balloon, since we're running nitrogen through the system, and I'll show you in there, we blow nitrogen over the top of the samples before we cap them, just to get that kind of equilibrated. And then the Kim wipe is just obviously to wipe the exterior of the cuvettes down.
Okay.
So, we have our little 1 glove on in the hallway, so this is where your pockets come in a lot of handy.
So you have to follow the policy.
For us. I don't know if you grab the needle or not.
You can use either argon as well, right?
Yeah, either or. Do you have a needle or? Oh, you have a needle? Yep. Okay. So I have. Do that instead of having to pinch it the whole time.
Right. So the balloon is ready now. We are going to cold room now. So this is the cold room. There we go.
So, yeah, but it feels nice. considering how hot it is outside. So, I mentioned earlier we want a 1 milliliter sample in each cuvette. So, make sure you calibrate the pipette, or I should say, change the pipette to 1,000 microliters. And then, obviously you can do it your own way. I like to just start with 0 so I know where I am, what I'm doing, etc. So obviously make sure, this is why we labeled them, make sure you have the right one. This is the 50 millimolar I know correlates to the cell 0. So, again, my tip. You probably don't have to do it, but again, I just like to mix these around a little bit. So, kind of go up, down a few times just to ensure everything is really mixed. Then just drop them in the cuvette. Put a little nitrogen over top. Cap it. And then again, wipe the outer walls
And the
of
cuvette.
the cuvette down. Next one, number 1, 100 millimolar. Use a different tip for each of these, obviously.
Are you going to upload for YouTube? No, just for myself only. We can do it actually. We'll get like 1,000 hits the first day itself.
And again, make sure that your open ends are going left to right. As you're looking directly at it, they should be going left to right. The little cheat is that you see where the light shines through.
Okay. Are you not feeling cold, man?
Me?
Yeah.
No, I love the cold.
Wow.
Feels
Wait.
great as far as I'm concerned. Almost always forget to wipe these down.
Are the cuvettes numbered?
Yep, they're numbered
It's
right on the interior here.
Okay, I can see that.
Alright, so yeah, these are the So this is basically ready to go now. And you want to, because we're starting at 4 degrees, and especially now because we don't even know what the stability of these duplexes are going to be. We'll walk fairly briskly over the TM, which again should already be controlled, set to 4 degrees. So now, again, take this guy, remove the bottom part, tap all these down, remove this lid, remove the secondary lid. You want to kind of get it so that number 0 is facing you, and you'll see it'll kind of twist into position when it does that. Put the cap back on, secondary cap, and hit run experiment. And now we wait.
Okay, there Eric.
I was already pretty close to 4 degrees. Yeah. Usually it doesn't equilibrate that quickly. Cell 0. Death knell by any stretch, but it's not a fantastic sign. Although now it's already down to 0.38, so
38.
I hope the lamp is
Working properly.
STD lights.
Yeah, it's, this thing's like dropping like a rock.
Yeah.
0.3433, yeah, it's
very
going down.
unusual.
Yeah.
Very unusual. Continuously dropping.